Hello, my name is Nathaniel Jose, and today I will be discussing Lab 2, Lines of Charge. So to introduce this lab, the purpose of the lab was to use charge tape to compare the point charge model to the lines of charge model, dividing the tape up into segments and creating each as a point charge in order to approximate a more accurate charge quantity for each tape. The key ideas explored in this lab were using tape to model electric fields of disturbed charge, using Newton's second law, F force equals mass times acceleration, and Coulomb's law, force equals Q times E, in order to calculate the charge on each piece of tape. Using superposition, dividing a charged object into segments and adding up the electric field of each in order to find the electrical net force, in order to find the charge distributed across a piece of tape. So the results were that F of gravity is equal to force of acceleration, which is these are from lab 1, 2.17 times 10 to the negative third newtons. The charge of tape is approximately 2.88 times 10 to the negative 8 C. Using superposition of segments provides a much different and more accurate result than treating the entire piece of tape as one point charge. The assumptions and one model. So the model, each piece of tape was modeled as several equal segments, with each segment here being modeled as a point charge, each with equal charge in order to apply the properties of superposition to find the charge of each. So the assumptions that were made in the lab were that air resistance is negligible, each piece of tape has the same charge, and charge of each piece of tape is equally distributed along the length. For the experiment, the system is tape B, which would be here. Surroundings is everything else in the room, including tape A. The initial conditions, two pieces of approximately neutral tape, also being about equal in length, and a third piece of neutral tape stuck down on my desk. Some details about the lab. Tape B was stuck to the tape on my desk and ripped off quickly in order to charge it, either leaving behind electrons or gaining more electrons through the process. The tape was then hung near several objects to determine its charge. It was finally placed above the other piece of similarly charged tape, tape A, until a portion of it floated, and the distance was measured between the tape and calculated its charge. So the data and calculations for experiment, the tape mass was 0.000221 kilograms, tape length was 0.221 meters, and the distance between pieces of tape is 0.0273 meters. Force of gravity is force equals mass times gravity, where 0.000221 kilograms times 9.81 meters divided by seconds squared is equal to 0.00217 newtons. Charge on tape is acceleration of tape is zero, so forces on it must be balanced, meaning force of electricity equals force of gravity. So here's the model and code of the math that we just explained earlier, where we have the square root of r squared to the magnitude. And then here are the models from the glow script code, where we have our initial positions and our final positions, and then our variable assignments. So as you can see here, in the initial, the magnitude of electric force is 4.69478 times 10 to the negative fourth newtons of force. And then after more calculations, we have 1.96294 times 10 to the negative 3. So, model discrepancies. More accurate model than for Lab 1. Still not perfect, as we broke the tape into a finite number of segments. The errors that could have occurred in the lab where a charge on each piece of tape may not have been totally equal, and that the charge may not have been equally distributed across the tape. So, what if you had modeled each of your tapes as a single point charge, like in the previous lab? So, and then compare the estimated value of the charge you get when you use the experimental data to produce a point charge model to the value you got with your line charge model. We did this before, but we had 1.34 times 10 to the negative 8 as opposed to 2.88 times 10 to the negative 8, which is a 53.5% difference between Lab 1 and Lab 2. So why do these estimates differ? Which value is more likely to be closer to the real value, and why? These values differ because each model has different assumptions and simplifications. These assumptions impact the estimated charge of each model and therefore lead to a difference. In reality, the charges are spread out along the surface of the tapes, and due to that, the line charge model from this lab was likely more accurate than the point charge model from the previous lab. Thank you for your time.